Hi students, in my last video that we have seen the basic introduction about the reciprocating compressors. So in this video that we will see the reciprocating compressors in detailed way. So first and foremost, let us see what is all about this compressor. So what is the compressor? The meaning of the compressor is it is a device that which is used to increase the pressure of air from low pressure to high pressure by some external energy. So in my last video I have explained clearly about this, what does that compressor do, and what is the principle, and how does that working principle will happen. So all these things that I have clearly explained, that how that air is sucked inside the engines, that compressor, reciprocating compressor cylinder, and then get sucked inside and then compressed, and then temperature and pressure will increase, and then finally it will be expanded, and that it will be discharged through the discharge valve. So this is all about the basic principle of this compression. Now let us see what are the applications where and all we use these compressors. See, the first one is for filling the air in tube of vehicles. So all these you might have seen on all the what you call where and all that vehicles, that air is to be pumped in the cycle, I mean tires, two-wheeler tires and cycle tires and all. So there you will find that air compressors which is connected to the electrical supply. Electrical supply will be given to run the compressor. So to fill the air in tube of vehicles, in automobile service station to clean vehicles, because that there to clean the vehicles you need high compressed or high pressured air is required. That is why there we use this automobile service stations. And for spray paintings in paint industries, so spray, if we want to spray to paint, so we need that high pressured air. In vehicle, to operate air brakes, for cleaning workshop machines, for supercharging of an IC engines, for operation of pneumatic tools, that is rock drills, vibrators, etc. In all these areas, these compressors, reciprocating compressors are used, where we get high pressured air. It is pressure will be immense, that is more than this atmospheric pressure. Alright, so how do we operate? It is operated by trapping a specific volume of air and forcing it into a smaller volume. That's what. So normally we take air inside the cylinder and we force it to a smaller volume so that it will be compressed, and that pressure will increase obviously. So the centrifugal pump. So we are talking about reciprocating so far. There is one more compressors are there, that is centrifugal compressors. How does it operate? It is operated by accelerating the air and converting the energy to pressure. So it is a centrifugal. It will be rotating with the help of that vanes. That is a different concept. So there reciprocation motion will not be there. There you will find only rotary motion. But here in reciprocation you find to and fro motion. So that is the basic difference between centrifugal compressors and reciprocating compressors. Now let us see the major classifications. Earlier we have seen only limited classification of these compressors. Now this is the the complete overview of the compressors, how it is classified and all. This compressor is classified in two types. One is positive displacement and one is a continuous flow. So positive displacement is nothing but the rotary one, and it is also a reciprocating one. So why do we call it as a positive? Because that it will run, so that will be compressed by some external force. So that is why it is called as a positive displacement. So it can be classified into rotary and reciprocating, rotary compressors and reciprocating compressors. If you see that rotary one, sliding vane, liquid piston, helical, lobe and screw type. So these are the different what you call types of this rotary compressors. But in our syllabus, that is only, I mean, reciprocating is only given for us, that we so this reciprocating is nothing but a mechanical piston. That is the basic model of this reciprocating compressors is a mechanical piston. And then continuous flow. Continuous flow is again classified into two types, dynamic and ejecta. So this dynamic is again classified into radial type or centrifugal, mixed and axial. So this is the overview of this compression and how it is classified. So now let us see some definitions of this compressors. So there are various types of terminologies are used. So the first one is compression ratio. It is similar to that of that internal combustion engine what we have studied earlier. It is a compression ratio. So it is defined as the ratio of volume of air before compression to the volume of air after compression. So how do we study the air compression ratio? Total volume divided by clearance volume. So that is what the compression ratio is all about. And then compressor capacity, so how much amount of air it can be filled inside in terms of meter cube per minute or meter cube per second. So that is what the compressor capacity is, a quantity of air actually delivered by a compressor. So that is nothing but the compressor capacity. Free air delivered, it is called as FAD. It is the volume of air delivered by compressor under the compressor intake conditions. So that is temperature and pressure. So this is the main thing, like a swept volume or stroke volume. So two names are given to it. It is also called as a stroke volume, swept volume or stroke volume. So the piston displacement from top dead center to bottom dead center, or forward movement and backward movement, or left hand side or right hand side, whatever we call it as, that depends on the arrangement of the cylinder. So that is nothing but the swept volume. So the definition will be like this: the amount of air is swept by the piston when it moves from one dead center to the another dead center is nothing but the stroke volume. So again, one more definition is the amount of air is swept by the piston when it moves from one dead center to the other dead center is called as a swept volume. So that is the definition of the swept volume. And clearance volume. See, if you look at the cylinder, when the piston is at the topmost position, and that is top dead center, uh, above the top dead center there is some space which is left empty. So that is nothing but clearance volume. So that will protect the inlet and exhaust valves to avoid breakage of that inlet and exhaust valves. Some amount of volume is left empty. So that is nothing but clearance volume. So here how it is given a difference between the total volume and swept volume. So it basically the gap that remains between the piston head and the cylinder head when at top dead center. So that is what the clearance volume is all about. Now coming to these efficiencies, there are different efficiencies like volumetric efficiency, isothermal efficiency, mechanical efficiency, and overall efficiencies. See, first one is a volumetric efficiency. So it is all about the how much amount of air in terms of volume it is occupied. So that will give you the efficiency of the volumetric. So the ratio of volume of air um, in one delivery stroke, that is actual air intake, to the swept volume, theoretical air intake by the piston during a stroke. So this is all about volumetric. That means, what does it say? So it is nothing but the amount of the air which is swept by the piston, that is swept volume, divided by the actual volume divided by the swept volume. That is nothing but the volumetric efficiency. In a very simple words that I can define the volumetric efficiency is the actual volume divided by the theoretical volume. That is nothing but volumetric efficiency. And then second one is isothermal efficiency, ratio of isothermal power to the indicated power. So IP. So isothermal power divided by the indicated power will give you the isothermal efficiency. Mechanical efficiency, this is very easy because in any cylinder working principle of this cylinders, so you will find two different powers. So it is indicated power and brake power. So that ratio will give you the mechanical efficiency. So it is a ratio of IP to the BP is nothing but the mechanical efficiency. Normally in engine cylinder, it is BP by IP because BP is taken as output and IP is input. So output by input will be the efficiency. But whereas in the case of compressors, it is different. So indicated power will be output and brake power will be the input, because we are giving the work to the compressor to compress. So brake power will be the output here, input here, and indicated power will be the output. So that is where the ratio is taken as indicated power by brake power. So that is nothing but mechanical efficiency. Next, overall efficiency. So it is the ratio of isothermal power to the shaft power. So that is nothing but overall efficiency. So this is all about what we have seen. So in this we have seen the classification part, and we have seen some definitions which are very important for our the study of this reciprocating compressors. The remaining topic will be covered in my next videos. Thank you.